And it's called what? Machine language, right? All right. So, and then here's talking about machine language. All right. Here we talk. It shows you. It reads information from secondary. Right. Read it into main memory, which is what? RAM. It's converted into what? Zeros and ones, and then it's processed by the CPU. That's all it's talking about. Now, this is called the fetch, decode, execute cycle. It's fetching instructions, it's decoding it, and then it executes it, right? So that's the process, right? Fetch, decode, and execute, all right? And again, same thing, fetch it, decode, execute. All right. From machine language to assembler language, all right? Going down, here we go. Now, look at this. This is a language that used to be, right? Prior to the first, second, third, fourth generation languages and fifth generation languages, you had like assembler language. Assembler language is a low-level language. And in assembler, you, like they had to do pretty much everything with numbers and whatever, addressing and whatever. But nowadays, we just declare a variable, we use it. It's integer, we use it as integer, do whatever. But back in the day, you had certain things you could do with values. You had, like say, if you was dealing with adding two numbers, you couldn't just say add A and B. You had to grab the data from the address it was located. You had to know where the address was. Then you had to take the information, unpack the information, do what you had to do, pack it back, and store it back into the registry. So it was a lot that you had to do as a programmer to accomplish what we're doing today, like in a little or no time. All right, but it still came up with the same results, but it just was. And machine language run faster. All right. When we get further down into programming, when you get 194, it's going to talk about pointers and addressing and whatnot. And you're gonna read that a program runs faster when it's dealing with pointers because it's not dealing with the actual value, it's dealing with the address, which allows the system to run a whole lot faster. All right, but like I say, we learned the C++ at this time, not assembler language, but it was a language that was used at one time, which was a low-level language. All right, so it says although assembler language makes it unnecessary to write binary machine language instructions, see, because it's low level. So it was not without difficulty. It was very hard. I had to program it when I was in school. It was hard to write in assembler because you had that system level, and you, like I say, you know it, dealing with addresses, dealing with whatever, and you have to know exactly what to do. All right. Assembler language is primarily a direct substitute for machine language. All right. It is like machine language. It requires that you know a lot. I mean, a lot about the CPU. All right. But we don't have to do that. Now we can write something in Windows, and we can use it in Linux or another operating system. All right. But with assembler, now you have to know the address we're going to put it at and whatever and stuff like that, which made it kind of hard. All right. Then now it's talking about the history of it and whatnot. But assembler language was a language that was machine level. Ada is a programming language. I used Ada before. Ada is somewhat similar to C++. Basic. Back in the when DOS came out, DOS had Basic. All right. Basic was used. It was a beginner's language, and it was pretty good. The only downside they kind of said with Basic was that you had go-to statements. So what happens is when you have go-to statements, I could have X number of statements. I could have an if statement and some information in that if statement. I could do a go-to inside that if. You understand? So with Basic, it's like your logic was not really flowing as fluently as and controlled as it could, because you could go to any point of your program at any time, which could have caused issues. All right, but it was a language, it was a beginner's language. Fortran more or less was a scientific language. It's like it took away a lot of things that you had to do prior to whatever. If I want to add 2 numbers, do this, add the numbers, boom, got my data. All right, because it was more or less scientific. You know, like scientists, they don't want to have to, well, I set this up to set this up to set this up, and then now write my code. No, they want to just put it in, do this, boom, got my answer. All right, so that was Fortran. COBOL was more or less a business type language, and my knowledge of it, a lot of times they use it for reporting, right? Like say you got, I think, who that was, Sears or what that other company, but most of those like Sears and whatnot, they use it for reporting, all right? So when they had to do big jobs of reporting, they maybe like the employee or the inventory, COBOL was the language that was used, all right? And COBOL, to like with I told you with Fortran, where you might use 5 to 8 statements to add 2 numbers. To do that in COBOL, you might need 40. You understand? Because you had to do so many sections. You had I forgot. You had input-output section. You had a procedure division. You had so many divisions, then you had sections within those divisions. So it's like so much you had to do. You had to put certain things in certain columns. That was COBOL. So it was somewhat structured, but it was like more for business reporting. Pascal kind of came around with C and whatnot, and Pascal kind of, not say similar to C, but somewhat like C, you know, but it got different coding language style to it, all right? C and C++, C++ is kind of derived from the C, C#, etc., you know, so they all pretty much in the same family, you know, similar code, but might have their little differences, all right, different libraries. Then you have your Java, and then your Java was also developed. But Java came about once they had the graphical, windows and screens where you can create JavaScript to move text, to change font sizes, colors, and all that stuff. You know, print message boxes and whatnot. That's how Java came about. But then you got JavaScript. JavaScript was created mostly for like web pages. Same thing. You could create a script to display a rolling text. You could create script to validate input and stuff like that. So the script, you didn't have to actually use Java, but you used the script to say, okay, I'm gonna use it to validate whatever. So that's all I'm using it for. I do that and I'm done. All right. Python. I've never used Python, but Python is used, I think, with a lot of different gamings and whatever games that they write and whatnot. All right, but Python is a lower kind of language where you can say, okay, print. You can say whatever, print 5 plus 4, into the print, the answer and stuff like that. But like I say, it's a language. All the language is pretty good. It depends on what it is you want to accomplish. All right. So as a programmer, I would say learn programs, but as you grow in programming, you're going to learn that you're going to have to migrate sometime to a different language depending on what it is you want to accomplish. All right. So it's just best to try to understand the concepts and then learn one as you want to. Okay, I want to learn this one. Dabble into it, learn it. Because the more you learn, the more you grow, all right? And the more versatile you can be. Ruby, I've never used Ruby. I don't know how it's used, but it says it's a general purpose language, all right, that was created in the 1990s, all right? Visual Basic. Visual Basic also was a language created with the Windows. And like I say, a lot of those Windows pop-up messages you get come from the Visual Basic, all right? When you get a screen that says maybe an error message or whatever, that's that Visual Basic, all right? So Visual Basic, and I think back when before what it was, Microsoft Office became as secure as it is now. Remember, you used to get those virus messages and errors. Visual Basic would throw those messages out to you. You know what I'm saying? When something would go wrong, it would throw out those messages to you. All right. So, and now high-level languages. Each high-level language has its own set of words that the programmer must learn. What that's saying? If I'm in one environment or learning one programming language, I have a set of rules, right? When I move to that other programming language, some of the rules might be the same, but they're gonna have some that gonna be what? Different. And I'm gonna have to what? Comply to those changes, right? Otherwise I'm gonna get errors. Everybody understand it? So each language has its own set of rules. It's kind of like the speaking language. We have English that has its own set of rules for what? How you write a paper or for communication. You have Spanish. It has its own what? Rules for how you write so you can communicate. So right, Russian, German, or whatever. Each one has its own what? Rules of how you write. All right, how to speak and communicate in that language. And the same thing with computer languages. You must follow the guidelines that apply. All right. Now, compilers and interpreters. You should read up on compilers and interpreters. The one thing I would tell you about compilers and interpreters, they work the same. You say what? What you mean, Mr. Mother? They allow you to take code, compile it, and generate executable file, provided that there's no what? Syntactical error. Now you say, okay, what's syntax? Syntax errors is errors that you get from not following the rules, all right? If it says put a semicolon after a declaration statement, if I use x equal 5 and don't put a semicolon in C++, I will get a what?
A syntax error.
I'll get a syntax error. That's a syntax error. But if I write a program and I'm supposed to be adding 2 and 2 to get 4, and my output is 8, that's a what type error? Logical error. And the program will run. You just have to find where you went wrong in your code, right? All right. So now, compilers and interpreters work the same, right? Except for one thing. A compiler will read through the entire program, trying to find all errors and then display them to you. An interpreter will read line by line by line until it finds an error and it stops. And then you have to fix that error. Then it reads, then you run it again, and then you bring it through the interpreter again, and it reads and reads and reads and reads and reads. Find an error, stop. All right? Until you get all of the errors out. Now, some programmers love compilers. Some love interpreters. It's all preference. You understand what I'm saying? It's all the programmer in the programmer's preference. Now, in a compiler, and you take your online GDB or your Visual Studio, when you write a program and say you forget to declare a variable at the beginning, or you mistakenly delete the line that says int amount is equal to 0, and then in your program you got amount is equal to whatever time, whatever, and you might have it maybe 15 different times. 9 times out of 10, how many errors you gonna get when it compiles? 15 errors. Every time it see amount, it's gonna say undefined, 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 undefined. So in that compiler, once I fix that one error, I might clear out what? All 15 errors. You understand what I'm saying? So even though it gives you those errors in a compiler, does not necessarily mean what? It is an error. How many people take their cars to the dealership and they put it on the machine, right? That machine gonna throw out a code if you have an engine check problem, right? It's gonna throw out a code. Now I'm gonna ask you this question. Just because it throw out a code and says that your catalytic converter is not working properly, is that necessarily the problem?
No.
Right, it could be anything before that, right? That's not working right to cause what? Once everything gets to it, to go bad. You understand what I'm saying? So you got, just like with that, you got to watch your code. You know, look at your code, look at the error message, make sure you understand what the error message is saying, and then try to logically figure, it's not time. Huh? Well, you must be gonna read a time when I get that next assignment. Hello? So you gonna know what we gonna have to do next class period. All right, class, we're gonna pick up here on next class period. Be looking, I'll probably post something, you know, for you to work on. All right? We're gonna complete software and whatnot, and then we'll probably have a test next class, next week, right? Because we're gonna complete, but really, hold on. I tell you what, finish reading up on this chapter. I'm gonna post chapter 1 test this week, all right? So I'm gonna post chapter 1 test from today until, till Monday at 10 at my 9 o'clock. So you make it to class, right? Everybody understand? So I'm gonna post test 1. Right? So read up on chapter 1. I need to do your paper. Mr. Sumter, oh yeah.
Yes, sir.
All right, everybody got this, right? So read up on chapter 1. Yes.
I'm still having trouble registering.
Oh, with the
Signing for classes.
what it said?
I think whenever I register